teaching. So I was asked like yesterday, and I didn't have a chance to let you know that I'm going to be absent. But whenever I'm absent, I try to make a class video so that you can still watch me teach and hopefully get as much out of this class as you can. I'm going to encourage you to take this time to work on these homework questions during the rest of the lesson. That was the plan anyway. And so we're not moving the quiz. The quiz will still happen on Wednesday. However, you can email me with any questions you have. Okay, so if you were going to attend extra help, just send me an email, let me know. Okay, okay, let's get started. So I've circled the questions I want to take up. So I will start with, got some new colors, which I'm excited about. And I'm going to start with question 1C. And so here we are just simplifying a rational expression. Okay, and so remember we can cross cancel. So I'll cancel the 12s, I'll reduce them, and that will become 1 and 3 because I've divided both integers by 4, right? 4 divided by 4, 12 divided by 4. I will cancel out the -5 and the -15, divide each by -5. That leaves me with a 1 and a -3. And so if we want to see where that leads us to, I'm left with 1. This is an intermediary step that you do not need to show. So I'm left with a 3, a -3, and an n to the power of 5. And so I see that the higher exponent for n is in the denominator, and as such, and that the difference between them is n cubed. So as a result, the n will be in the denominator. The numerator has a value of 1. The 3 times -3 is a 9, and I generally like to keep my negatives either in the numerator or in front of the fraction. And then we list our one restriction, which is that n cannot be equal to 0. Moving on to question 2D. That's right. Okay. Let's choose a magenta color. 2D. We've got -8t to the power of 4 over 3 divided by -6t squared over 5. Now, because I'm dividing, I need to write the reciprocal. -8t4 over 3 times 5 over -6t squared. Okay, so let's check. I cannot cross cancel the 3 and the 5, so they remain. I can cross cancel the -8 and the -6, so we'll divide them by -2. That leads me to 4 and 3. And then the higher exponent for t is in the numerator. So we'll have t squared, 4 minus 2, in the numerator. We have 4 times 5, which gives me 20, and 3 times 3, which gives me 9, such that t cannot be equal to 0. Moving on to 3D. -4a over 7b cubed. And I'm just going to write the reciprocal right away. Right, so times 7 over -8a to the power of 4. Let's start with the 4's. So cancel out the -4 and the -8. We end up with 1 over 2. The 7's cancel out nicely, and they end up as 1, 1. And then we've got the a's. So this a has an exponent of 1, right? We generally don't write it. And so because the higher exponent is in the denominator, 4 minus 1, a cubed will be in the denominator. B, there is no b in the numerator, so we leave it as b cubed. And then we've got 1 times 1 in the numerator, 1 times 2 in the denominator, such that a and b cannot be equal to 0. Purple. Moving on to 4F. Okay, I've got to copy this down. 4F. We've got 4a squared b squared c over negative 3ab. And now we've got a reciprocal, right? So let's just make a red or a pink times to show that we're writing the reciprocal. So what is the reciprocal of 6c squared? Well, if you make 6c into a fraction, so 6c squared over 1, and then you flip that fraction, you get 1 over 6c squared. So this is the reciprocal here. Okay, let's move on to cross-canceling. So I see that the 4 and the 6 can both be divided by 2. That gives me a 3 and a 2. And one of the mistakes that I could see someone doing is cross-canceling the 3 and the 6 over here before you write the reciprocal. So do not cross-cancel until everything is being multiplied. Okay, next, let's see what we've got. So I have a to the power of 1, b to the power of 1, and c to the power of 1. So I like to write that in just as a reminder that the exponent is 1. Okay, so numerically in the numerator, I have 1 times 2. In the denominator, I have negative 3 times positive 3. That gives me negative 9. Okay, let's look at the a. So I have a squared, and a1 means a1, or a to the power of 1. B squared over b to the power of 1 means b to the power of 1. But c, the greater exponent is in the denominator, meaning c squared minus c to the power of 1 will give you a c to the power of 1 in the denominator, excuse me. And so, as I said, I prefer the negative sign in the numerator or in the front of the fraction. In terms of good mathematical communication, we do not include a 1 as an exponent in the final answer. And now looking at the restriction, I notice that a and b and c all end up in the denominator at some point. So a, b, and c cannot be equal to 0. Okay, pause if you need to. Moving on to question. What am I moving on to? Question 5. Where'd you go? There you are. Green, I feel green. Okay, so we are looking at 5F. What do we got? Okay, so I've got 3m plus 4 divided by 5m. Here I am just copying out the original expression. Remember, this is an expression as opposed to an equation. An expression does not have an equal sign. Okay, so it could be a bunch of polynomials or rational expressions multiplied. And since we don't have any equal signs, this is an expression. So we're not solving, right? If we had an equation, we would be solving. All we're asked to do is to simplify. Okay, so we're going to factor and cancel in order to simplify. All right, no need to write a reciprocal. Let's see what we can cross-cancel. 3 and 2 cannot be cross-canceled. 5. Well, look, the 6 and the 2 can be reduced, divided by 2, to 3 and a 1. Great. Ooh, m plus 4 and m plus 4 can be cross-canceled. And m to the power of 1 and m to the power of 3 will be reduced. I'll actually cross out the 3 and write a 2 as a result, giving me 3 times 3. So the coefficient becomes 1, m squared, right? 3 minus 1. The coefficient of the denominator is a 5, and there's nothing else in the denominator. So that's where we end. Now for the restrictions, remember, yes, m cannot be equal to 0 because m is on its own in the denominator. Also, we have this expression, this binomial of m plus 4. So if m is negative 4, this binomial equals to 0. What have I not done? Oh, great. Let's look at 6a. Okay, here we're starting to talk business. All right. And so in this question, I see I have a lot of common factors. So step 1, check for common factor. Factor out the 4, I've got x plus 1. Factor out the 3, I've got x minus 1. Times factor out the 6, x minus 1, starting to look good. Factor out the 5, x plus 1. Oh, beautiful. I can cross cancel the x plus 1s. I can cross cancel the x minus 1s. And now let's look at the coefficients. So the 6 and the 3 can be reduced to 2 and 1. Okay, so I've got 4 times 2, that's 8, divided by 5 times 1, that's 5. Okay, let's say you forgot to reduce the coefficients and you ended up with 4 times 6 is 24 over 3 times 5 is 15. Then you could see if you could reduce this fraction any further, and you could by dividing each by 3. All right, let's see where the restrictions. Even though we don't have the variable in the denominator right now, at some point the variable was involved in x minus 1 and in x plus 1. And so that tells us that x cannot be equal to positive or negative 1. That's it. Those are the only restrictions. Great. And I think we've got one more question for yesterday's homework. I'll make a second video for today's classwork / homework. 7C, we're looking at m squared minus 3m minus 4 all over m squared plus 5m. And I'm going to write the reciprocal right away, times. So I'm going to take the denominator, m squared plus 2m minus 15, and the numerator becomes the denominator. Okay, let's work on this one. So again, what do? I just simplify. Okay, and so we have some simple trinomials here. And so for the first one, I'm looking for two numbers that add up to -3, multiply to -4. They are going to be -4 and +1. In the denominator here, I see there is a common factor of m. So in this kind of complicated solutions, it might make sense to write your restrictions as they come. right? So you might start a list. Okay, m, this one tells us that m cannot be equal to 0. This one tells us that m cannot be equal to -5. Okay, let's see what else we got. Adds up to 2, multiplies to -15. Okay, it's going to be 3 and 5. And because it has to add up to 2, it has to be +5, -3. Okay, and let's simplify. So let's factor this last term. So what adds up to -7 multiplies to -12? It's going to be -4, -3. Okay, everything is factored. Beautiful. Let's see if we have any more restrictions. Yes, we have a restriction that m cannot equal to 3 and m cannot equal to 4. Okay, let's start cross-canceling. So I see I can cancel m plus 5 and m plus 5. And I see I can cancel m minus 4 and m minus 4. And m minus 3 and m minus 3. So if you have a lot to cross-cancel, it gives you a good sense that you probably factored correctly. And here we go. And remember the big mistake. I want to cancel the m's. No, you can't, because m plus 1 is being added, not multiplied. So here's the answer, such that let's list the restrictions. M cannot be equal to 0, -5, 3, and 4. And then I might go through my entire solution again to make sure that I didn't miss any restrictions. For example, I'll see, oh, was this a division question, right? Was the numerator originally in the denominator? Is that true? It was. Ooh, look, look. Okay, Miss Sly. Because we wrote the reciprocal, this means that this numerator used to be in the denominator. So I must consider m plus 5. Okay, I did. And m minus 3, done. So these factors are included. Those restrictions are included. Great.